Introduction. Classification is a two-step process, particularly learning step and prediction step in machine learning. In the learning step, the model is developed based on a given training data, while in the prediction step, the model is used to predict the response for given data. Decision tree is one of the easiest and popular classification algorithms to understand and interpret.
Assumptions. In the beginning, the whole training set is considered as the root. Future values are preferred to be categorical. If the values are continuous, then they are discretized prior to building the model. Records are distributed recursively on the basis of the attribute values. Order to placing attributes as root as internal node of the tree is done by using some statistical approach. Definition. Supervised learning, also known as supervised machine learning, is a subcategory of machine learning and artificial intelligence. It is defined by its use of labeled datasets to train algorithms that to classify data or predict outcomes accurately. Decision trees are types of supervised machine learning that is you explain what the input is and what the corresponding output is in the training data, where the data is continuously split according to a certain parameter. The tree can be explained by two entities, namely decision nodes and leaves. The leaves are the decision or the final outcomes, and the decision nodes are where the data is split. A decision tree is a support tool with a tree-like structure that model probable outcomes, cost of resources, utilities, and possible consequence. Decision trees provide a way to present algorithms with conditional control statements. They include branches that present decision-making steps that can lead to a favorable result. Decision trees are one of the best forms of learning algorithms. They boost predictive model with accuracy, ease in interpretation, and stability. The tools are also effective in fitting nonlinear relationships, since they can solve data fitting challenges such as regression and classifications.
Decision tree algorithm belongs to the family of supervised learning algorithms. Unlike other supervised learning algorithms, the decision tree algorithm can be used for solving regression and classification problems too. The goal of using a decision tree is to create a training model that can use to predict the class or value of the target variable by learning simple decision rules inferred from prior data or training data. Also, in decision trees, for predicting a class label for a record, we start from the roots of the tree. We compare the value of the root attribute with the record's attribute. On the basis of comparison, we follow the branch corresponding to that value and jump to the next node. These are the different algorithms used in decision tree. First is the ID tree or extension of D tree. ID tree uses a top-down greedy approach to build a decision tree. In this, we start building the tree from the top, and the greedy approach means that at each iteration, we select the best feature to create a node. The next is the C4.5, or also known as the successor of ID3. In this algorithm, it uses data mining as a decision tree classifier. Next is the CART or classification and regression tree. In this algorithm, a binary tree is built by splitting node into two child nodes repeatedly. Next is the CHAID or chi-square automatic interaction detection, which performs multi-level splits when computing classification trees. The last one is the MARS or multivariate adaptive regression splines. It involves finding a set of simple linear functions that in aggregate result in best predictive performance of the tree. So when do we use decision tree algorithm? Decision trees are commonly used in operations research, specifically in decision analysis, to help identify a strategy most likely to reach a goal, but are also a popular tool in machine learning. Also, decision trees are extremely useful for data analytics and machine learning because they break down complex data into more manageable parts. They are often used in these fields for prediction analysis, data classification, and regression.
An example of a decision tree can be explained using binary tree. Let's say you want to predict whether a person is fit given their information like age, eating habit, and physical activity. The decision nodes here are questions like what's the age, does he exercise, does he eat a lot of pizzas, and the leaves which are outcomes like either fit or unfit. In this case, this was a binary classification problem or a yes-no type problem. There are two main types of decision trees that are based on the target variable. These are categorical variable decision trees and continuous variable decision trees. The first one is the categorical variable decision tree. A categorical variable decision tree includes categorical target variables that are divided into categories. For example, the categories can be yes or no. The categories mean that every stage of the decision process falls into one category and there are no in-betweens. The second one is continuous variable decision tree. A continuous variable decision tree is a decision tree with a continuous target variable. For example, the income of an individual whose income is unknown can be predicted based on available information such as their occupation, age, and other continuous variable. Here is an example. Let's say we have a problem to predict whether a customer will pay his renewal premium with an insurance company. Here we know that the income of customers is a significant variable, but the insurance company does not have income details for all customers. Now, as we know this is an important variable, then we can build a decision tree to predict customer income based on occupation, product, and various other variables. In this case, we are predicting values for the continuous variables.
Now, I will show you a graphical representation of parts of the decision tree. First, root node. It represents the entire population or sample in this folder gets divided into two or more homogeneous sets. Next, splitting. It is a process of dividing a node into two or more subnodes. Next, decision node. When a subnode splits into further subnodes, then it is called the decision node. Next, leaf or terminal node. Nodes do not split is called leaf or terminal node. Next, pruning. When we remove subnodes of a decision node, this is called pruning. You can say the opposite process of splitting. Branch or subtree. A subsection of entire tree is called branch or subtree. Last part. Parent and child node. A node which is divided into subnodes is called a parent node of subnodes, whereas subnodes are the child of a parent node. Applications of decision trees. Number 1. Assessing prospective growth opportunities. One of the applications in decision trees involves evaluating prospective growth opportunities for business based on historical data. Historical data on sales can be used in decision trees that may lead to making radical change in the strategy of a business to help aid expansion and growth. Number 2. Using demographic data to find prospective clients. Another application of decision tree is in the use of demographic data to find prospective clients. They can help streamline a marketing budget and make informed decisions on the target market that the business is focused on. In the absence of decision, the business may spend its market without a specific demographic in mind, which will affect its overall revenues.
And these are the advantages and disadvantages of decision trees. One of the advantages of decision trees is that their outputs are easy to read and interpret without requiring statistical knowledge. For example, when using decision trees to present demographic information on the customers, the marketing department staff can read and interpret the graphical representation of the data without requiring statistical knowledge. The data can also generate important insight on the probabilities, costs, and alternatives to the various strategies formulated by the marketing department. Then easy to prepare. Compared to the other decision techniques, decision trees take less effort for the data preparation. However, users need to have ready information to create new variables with the power to predict the target variables. They can also create classification of the data without having to compute complex calculation. For complex situations, users can combine decision trees with other methods. Third, less data cleaning required. Another advantage of decision trees is that there is less data cleaning required once the variables have been created. Cases of missing values and outliers have less significance on the decision tree's data. Fourth, possible to validate a model using statistic tests that make it possible to account for the reliability of the model. The last, perform well even if its assumptions are somewhat violated by the true model from which the data were generated. And these are the disadvantages of decision trees. Unstable nature. One of the limitations of decision trees is that they are largely unstable compared to the other decision predictors. A small change in the data can result in a major change in the structures of the decision tree, which can convey a different result from what users will get in a normal event. The resulting change in the outcome can be managed by machine learning algorithms such as boosting and bugging. Second, less effective in predicting the outcome of the continuous variable. In addition, decision trees are less effective in making predictors when the main goal is to predict the outcome of a continuous variables. This is because decision trees tend to lose information when categorizing variable into a multiple categories.